Okay, so composition of functions. You can tell if you look at this, it looks like what that you did earlier in the year. Do you guys remember what this stuff's called? It's just function notation. Remember when we had a little worksheet where they asked us to find, like f of 2. They might ask us to find f of x equals 14. They might ask us to find, given f of x and g of x, write g of f of x. Remember doing that scientific notation a little bit? Okay, and so we just set it up, and sometimes it was like given x we were solving for y, given y we were solving for x. But today we're going to use the function notation, composition of functions style, so we can check to see if two equations are inverse. So it's kind of cool. This is new for Algebra 2. That's what we're doing. We're verifying to see if it's an inverse. So to evaluate, we simplify the inside set of parentheses and we work outwards. So the first thing I want to verify is g of f of x. And then on this side, I'm going to verify f of g of x. I think I want to save number 1. Let's start with number 2. So number 2 is going to be a very similar looking problem, but we'll come back and do number 1 after we do number 2. If the two equations are inverse, then when we find g of f of x, it's going to equal x, and f of g of x is going to also equal x. If they don't equal x, then they're not inverse. So let's start with number 2. So first we're going to find, this one's a little different, the letters are different. We're going to find k of h of x. And then to verify this one, we're going to find h of k of x. And so the reason I wanted you to have 2 colors, make the first equation a color, make the second equation a color. Try not to write over your equation. There you go. An easy way to set this up, because we want to start inside the parentheses, when you see h of x, you're just writing that 2x minus 6. That's what h of x is. Okay, and then we're going to build outside of it. So outside of it is my k. This is my new x. So in front, I have 1/2, and on the end, I have +3. Okay, so that'll kind of help you set it up. Okay, instead of k of x, we replace the x with h of x. So I started from the inside, wrote my h of x, and then I just built k around it. So now we're just going to see what we get when we solve that expression. So 1/2 times 2x gives me 1x. 1/2 times -6 gives me -3. And then I have +3 on the end. -3 and +3 cancel out, and I'm left with x. So it works. These are inverse. Okay, so one of the harder things to do is just setting it up. So on this one, the inside is k of x. So inside I have 1/2 x plus 3. And then around it, I have to build my outside, which is h of x. So around the x, in the front I have 2 times, and in the back I have -6. You with me for setting it up? Okay, so now I'm going to distribute. So 2 times 1/2 x gives me x. 2 times 3 gives me +6, -6. My 6's cancel. I'm left with x, which tells me they are inverse. Okay, if when you find k of h of x and its inverse. On your homework, you're also going to have to show h of k of x, but you have to do them both. But you should get inverse for either both of them or not inverse for both of them. It's not possible that you could get inverse for one and not inverse for the other one. Okay, but this is a good way to check it. Anybody still writing? So now I want to go back to number 1. Because I kind of wanted you to see what it looked like first before we do number 1. So here's my f of x. Pick a color for that one. Here's my g of x. So I'm going to start for the middle. For the inside, there's my f of x. And then it's in g of x. So really, I'm just writing that little part right there, and then I have to put 3 times in front of it and minus 5 at the end of it. Then we're going to distribute. So I get negative 9x plus 15 minus 5. So 3 times my negative 3x gives me negative 9x. 3 times my 5 is 15, and minus 5. Combine like terms. Does it equal x? No. It does not equal x, so it is not inverse. Okay, I should still set up and try the other one. So this time on the inside is g of x. Around it, I'm going to build f of x, so it's multiplied by negative 3 in front of the x, and then add 5. When you distribute, you get negative 3 times 3x is negative 9x. Negative 3 times negative 5 gives you positive 15 plus 5. Negative 9x plus 20 does not equal x, so it is not inverse. Okay, if you get not inverse for one of them, when you substitute in the other one, you should get not inverse. That's why I didn't want to do that one first, because I'd rather you kind of see what it looks like first. Sure. Sometimes the problems will get a little bit harder. Number 3 is probably about as hard as it's going to get for Algebra 2. It's just a little bit more difficult, but it's really the same idea. You're just substituting one function into the other function to see if it equals x. Very good? Okay, so my first function, what kind of function is that one? It's a quadratic, right? My second function is a square root. So the first thing I'm going to do is I'm going to try g of f of x. So f of x, which is what's on the inside, is x plus 3 squared minus 7. Okay, I might even put like another set of parentheses around it, because this is where it is. It's that x. So I have to build that other stuff around it. So I'm going to have a square root symbol. And under the square root symbol, after the x, I also have that plus 7 under the square root symbol. And then I have that minus 3 on the outside of the square root symbol. Okay, so let's take a look at that. If my squared is followed by negative 7 plus 7, but they're both under the square root symbol, I'm allowed to touch that, and they cancel out. So now I'm left with the square root of x plus 3 squared, and I still have that minus 3 on the outside. So what would you cancel out next? Good. Square root and squared cancel out, so that frees up what's underneath. Then my 3's cancel out, and so it equals x. So they're inverse. Okay, so the setup on this one's just a little bit harder because they're a little bit bigger functions. So on this one, we're going to find f of g of x. So I start with the one that's inside, the square root of x plus 7, and I have minus 3 on the outside. Then, so this is all that I have right now, is that x. So I'm going to build around it. I have parenthesis, and then I have plus 3, and then I have parentheses squared minus 7. Okay, so when I go to solve it, because all of this is in squared, I'm allowed to cancel out minus 3 and plus 3. So now I'm left with x plus 7 squared minus 7. And now what would you do next? The square root and the squared. I can't do the 7s yet because they're not out from under the square root symbol, so you should really show your work in the order that you can cancel. And then my 7s cancel, and so this is inverse. Okay, so just make sure that you try to go in the order that you can cancel. You're not allowed to cancel under the square root until you get rid of it. What do you think? Not too bad? Okay, if you just had a schedule change, that's about as bad as they're going to get. Okay, not too crazy, because sometimes they can be really big problems. Okay, the last one. What kind of functions are these? Anybody know what kind of functions they are? We kind of talked about them a little bit yesterday. Yeah, they're cubed and cubed root. So the first one we're going to find is k of h of x. Okay, and y'all can do this even though we haven't studied cubics. That's our next unit. So I'm just going to replace h of x with my x minus 8 cubed. So that's this part. And then around it, I'm going to put my third root and then a plus 8 on the end. So what am I allowed to cancel right now? Not yet, because I have to get rid of the cubed. The cubed squared, or the cubed root, and the cubed. And then I have the x plus 8, or x minus 8, and then the plus 8. Because that cubed cancels out the cubed root. So I can get that out from under there, then cancel out the 8s. And it's inverse. So the next one we're going to find is h of k of x. So my k of x is that third root of x plus 8. It's that whole thing. So it's like just the x. And so I have to build the rest of it around it. So I have those parentheses, and then on the end, minus 8, and then cubed. Okay, so on this one, all this stuff is in the parentheses before it's cubed, so I can actually cancel out what first? The 8s. Good. And so then I bring down the cubed root of x cubed, and then I can cancel the cubed root and the cubed. Okay, so this is verifying that they're inverse with composition of functions. How else can you verify that they're inverse? Because we're going to do kind of a big practice tomorrow. What other ways did we learn? Day 1, what could I do with my calculator? I could type 1 in y1, 1 in y2, and look at what? You could see if it's a reflection across y equals x. What else could you look at? You could look at the table and see if it's flipped. And then last night when you did those equations, what could I do with the first equation? I could take either of these equations, maybe not cubed root because we haven't done it yet, but I could take one and I could switch x and y, and when I find the inverse, it should be the second equation. which is what we used to do in Algebra 2. But now we're just learning composition of functions also. But they won't be too bad. The problems won't get too much harder than that. That'll be about all you see. I don't know where the thing went. Oh, there it is. I'll have to shorten that.